We started with mutate today. Okay. Can you see the book club on the book down documents, the summarized slide versions for this book club discussion actually? Can everyone see?
Yes.
Okay, good.
Yep.
So chapter 5.6 said add new variables with mutate. So, mutate add new columns based on values from existing. Oh, hello everyone. My name is Matthew. So I'll be taking this discussion. How's our day going?
It's been good.
Oh, good. So I just went straight to business without saying hello or exchanging pleasantries. Okay, so let me go ahead and kickstart so we can cover much ground today again. Adding new variables with mutate. The mutate function actually add new columns based on values from existing columns. Data frame include existing and new columns. So flights _7 underscore colon. This select. Okay, we've already assigned that. We gave ourselves a task to go through the select function itself and also the arrange function. I believe we were able to do that before today's class. So the select function just selects columns, and what this mutate function does, it creates new columns. And for example, this particular chunk of code says calculate and add columns for gain, hours, and gain per hour. And this calculation here is this departure delay minus arrival delay to get the time gained, or the difference in time for that particular flight. Then the hours, and what's converted to hours. And so for that we get this calculation on gain per hour. That's because the departure delay is actually in minutes. Yes, it's in minutes. So divided by 60, it now gets it in hours here, gain per hour. So with that, we have a new column here, and that's the gain per hour column here. The gains and also the hours column here, and both are actually added to the new table that's been created. So mutate generally just adds new column to the existing data frame. So there's another function called transmute. What transmute does is it adds new columns based on values from this column, but this time around it's just those new the newly added columns that would be on this table, on the newly created table. For example, this table here, is just for the gain, the hour, then the gain per hour. So to the next chapter, the next subtopic, that useful creation functions. So there are other functions we could use under mutate, or yes, other functions we use alongside mutate. There are many functions used to mutate. The function must be vectorized. It must take a vector of value as input and return a vector with the same number of values as outputs. And we have the arithmetic operator, the plus, minus, times, divide, and raise to power. All this actually we used this this was used for the one of the gain, the minutes gain that was converted later to hour. We divided by 60. That means we used one of the arithmetic operator there, divided by 60. So also we could use the modular arithmetic function, the integer division, and also remainder. Then also for the we could use logarithm. Well, I really don't know how to use this properly. So I'm not using this in any data I've analyzed before, the logarithm part. I wonder how it is used though. So the offset part, this has to do with leading values, then lagging, the lag function for lagging values. Then there's the functions also for cumulative and ruling aggregates. There's the function for cumulative sums and cumulative products, and cumulative minimum, then cumulative maximum. They also have that for cumulative means. Then logical comparison, we also have a function for logical comparison, the less than and less than equal to, greater than equal to, the not operator and the equal to sign, that is not equal to, that's represent inequality, I think. Then this should be for equality, the double equal to signs. Then ranking, minimum rank gives rank from smallest to largest. Then minimum rank with the DSC, that's descending, gives ranking from largest to smallest. Then row number and that. So testing out various functions to see what they do. I think I should run this part of the code then on RStudio. Come back to this. Is my RStudio IDE visible?
Yes. Yes. Yes.
Oh, great. So let's just quickly before we will still mutate, add new variables. Okay, so useful creations. Okay, so let's just run that chunk and see what it's saying. Transmute. The transmute function also works like other functions in the tidyverse package. The transmute function, the first argument it takes is the data set, then later it takes the column of interest, and afterwards we could use the useful functions that we mentioned earlier, such as the modular arithmetic and the normal arithmetic. That's now we're using the subtraction or the minus function here, then logarithm and the lead duration. So let me just run that. But I just don't know why, but okay. Nans produce. Okay. So this is what it runs. It gives us new data, a totally new table having the new columns that has been created. So to the next chunk, that is this next chunk also has us create now we're using the cumulative aggregate and logical comparison, then also the ranking functions. Now running this, we have a new table having these different columns with data set of interest, and also ranking their duration and how long it took. Okay, yeah. So what this logical comparison function does is, okay, for duration greater than 300, it tells us, okay, this is true and this is false. And the next chunk, group summaries with summarize function. So we're going to the next function, and that's the summarize function. And this collapses the data frame to a single row. And by default, summarize includes the NA values. So summarize will return NA if any values are NA. So this will pose a big challenge. And we talked about missing values in the last class, I think. And missing values actually causes a whole lot. If they're missing values in the data and we go ahead to summarize, it means that we will not get what we intend to get. Then we have to actually take out the missing values. So there's actually a function that makes that possible. And I think that was mentioned. That's the na.rm equals true. That is, you can easily just remove the missing values. So to the next chunk of data, now the missing values are removed. Let me just run this. We get to know the mean for the time which the departure of those flights were delayed, and we get it to be 12.63. I think it should be in minutes. Okay, so let's go to the next chunk. Okay, let's go back to the book. And okay, so that'll be that for okay, group summaries. Yeah. So this part we use nrow. Okay, we already know about nrow and the filter function and is to check the NA values for a colon. So it's what we're just, I think what this part is just trying to like show us now is, okay, we can still go back and check, are there missing values? Okay, these missing values, how can we get them off? Then we could easily just use the is the NA, are there missing values? Oh yes, there are missing values, and we can get to remove the missing values. Now use summarize and group by to calculate values for each group. So for this particular chunk of code, what we are doing now, we are grouping the flights by day. And so I'll go back to RStudio to run each line of this code. Okay, so sorry. Okay, by day, group flights by year Monday to get daily flights. Okay, so we at first will store the output of this grouping in an object called by day. Then afterwards we summarize this and get the mean for the departure delay, removing the missing missing value. And that's what we have this table here, which has 365 by 4 column. And that simply means that we just have for each of the days in a year. So when we have 365 days in a year, that means that that particular year is actually not a leap year. So it has been 366 days. So combining multiple operations with the pipe, use pipe to perform multiple operations on a data set. Do step one and then okay. Now for this, how this work is for ggplot to most times use the addition sign to add more functions or to perform other tasks. But for other functions in the tidypath package, we actually use the pipe operator. And so it goes like in the flight data set, group the data set by year, month, day, then summarize the data sets by finding the mean for the departure delay column, and missing values are present in the data in the data set. So when we run this, automatically missing values are taken off, and the same thing we did up there in the last chunk of codes, the same thing that we're also doing here. But this time around, we are doing everything compressed in one let's say set or chunk of code now. Okay, so that aside, counts. Whenever you do any aggregation, you should include a count of values or a count of non-missing values. That sum is .na, and to check of items per group. So to get flights, so we're going to do this using this get flights that were not cancelled. Now I want to know the flights that were not cancelled for this part in this particular flight data set. And to do this, we'll run the flight data set, then filter the trips that were not cancelled or the trips that were not delayed. Then also filter out, okay, is the NA now the trips. Now, if there's a missing value, it simply means that the flights actually get flights that were not cancelled. Okay, if that is not delayed, that means the flight is not cancelled. That there is no missing value there means the flight was not cancelled, and also there's no missing value in the arrival. Delayed arrival means the flight is not, that flight actually is not cancelled. So if you run that particular chunk, let me run this first then. So now we have this not cancelled. The flights that were not cancelled are stored in the not cancelled object, and afterwards we can now go ahead and group them by the tail number. And after grouping this flight by tail number, we can then calculate the mean arrival delay and number of not cancelled flights for each tail number. So for each of the airplanes, by their tail number, we get to calculate, okay, what is the mean arrival delay for each of these planes and the count. So we have this particular table out here, which is a table of about 4,000 by 3 columns. So we had about 4,000 airplanes in this particular 4,000 airplanes in this particular flight data set, and we would have to sort to get the minimum delay or the maximum to find out, okay, what's the highest or the lowest time that was spent, like when you had delays in the airport. So the next thing is to go to the next chunk, combine GPLYR, like the deployer package with ggplot2 to rearrange and plot data. So DPLR and the rest of tidyverse use the pipe function, while ggplot uses the addition sign to add more functions. So pick the delayed flights with more than 25 flights and then plot the flights. So what we just did is we're picking flights, the flights more than 25, then we're plotting to see what happens there. Okay, let's do that. Okay, sorry. Okay, so this is what the output is like. I think it would be better if I do that there. Okay, so yes, so this is what the flights is going to look like. So we had several flights that we have several outliers. We have this outlier here, and we have some planes that came in very early, like about two tail number, two tail numbered planes or so that came in early, and this one's come very late, close to an hour late most of the time. Okay, so useful summary functions. Many functions can be used with the summarize function. And measure of location, such as median, values where 50% of x is above it and 50% is below it. Okay, measure of spread, standard deviation is actually the standard measure of spread, interquartile range. There's several other functions that can actually be used. Now, count the number of flights per destination. Now, with this, we are going to be grouping. We're going to group the flight, the not cancelled table by destination. Then we'll also count again. And doing this, we found out that these flights were to 104 destinations, and we had counts to this particular destination. So for ABQ, and we had about 254. I don't know the state code for that. I don't know which country had a state code, though, or maybe a state or so. I think the flights is, I don't know. So there were 254 flights for that particular destination. The ACQ had about 264. Maybe this LB is Albana also. Had about 418 and several other destinations like that. So I believe if when we arrange the data sets, we'll find out which of the destination had more flights to its destination. Now count the number of flights per destination. I think we have done that earlier. Okay, what's different now? Okay, we use the summarize function to count there, but now we are using the count function in this chunk of code here, and we get a similar output, 104 by 2. The table is 104 rows by 2 columns, and use sort true with count to sort the count. So now we can add an argument, which is the sort argument, and assign it and use the true and say it's true to get the data sorted. And here we'll find out that this particular destination ATL had more visits compared to other then followed by ORD, LAX. I think this is Boston, MCO, and CLT. Maybe this is San Francisco. I don't know, SF. Then we have them arranged now from the most flights to the least, the destination with the most flights to the least. Then optionally, okay, I think there's a chat. Will it be possible to sort in ascending order as well? Yes, it's possible to sort in ascending order. Maybe I should go back to RStudio to try that out. Okay, so count useful summary. Okay, let's see that sort true with counts. Okay, so we could just make sort and make true false. And also, I think in the last Cohort 5, when I was checking their video out, I saw John was trying to explain the fact that it may not necessarily be true that should be here. You could use 1. True is actually 1, then false is 0. So if we use 1, we'll most likely, let me run this first. And this is what we get. If we use 1, we most likely will get the same thing. And so if let's make it false first, so we can, yes, we can use F. But for readability's sake, yes. Okay, false. Why am I not getting this? Why is it not? Yes, we can sort the other way around. What's going on? What's going on? Okay. Sorry, let me check the help page, because that's what I do whenever, but I know it's possible to actually do it the other way around too. Is there any? Okay, there's no message on chats. Let me check. Okay. If false, we could count for empty variables. Okay. Sort is true. Sort is true. Sort is true. You should larger group at the top. Then if false, you should show the other one. Show the one. False and true. Okay. Okay. There's a chart. Sort should do the trick. Okay. Sort function. I saw your message. So let me try it and see what happens then. Oh, are you saying the sort function should be, because there's a sort argument in counts? Do you mean, I didn't get you there, Adiemi. Do you mind unmuting to speak, or Mr. Adiemi? I saw your message, but anybody to the rescue? Okay, I'll be sharing my audio. Okay, no problem. Okay, so come in. Should be real. Let's try sort equals to try. Okay. I'm not sure about using sort to the count function. I'm only aware of using the des argument in the sort function. Okay, Vinda said so. Okay, let's try using the sort function in the okay. Oh no, that's not it. Okay, let me try what Vinda just said. Sort function. So decreasing equals false. Okay, not cancelled, comma decreasing equals false.
To me, it looks like the way that the sort argument is set up in the count function, that it could only take true or false, it looks like. So I'm wondering if you could sort before you used count, and if that could, you know, achieve the descending and ascending order.
Can you come again? Is that Vinda? Can you come again, Vinda?
Yeah, sorry, I was just wondering if we used sort before count, like used the sort function and then piped that into count, if that would solve the problem. I'm not sure.
Okay, let me do that then. What you said, is that what I'm doing? Sorry. Okay, then the sort function then takes the arguments. Increasing equals false. Increasing equals false. That's increasing equals false. Increasing. Let's see if this works. Okay, it doesn't. Didn't work. Okay, I got another message. Not cancelled. 5. Okay. That's what I did, Shannon. Oh, sorry, didn't finish that. Okay. I would wait. When I get that, I'll do what you send them. Govinda, I don't know. Is this what you're saying? Is this what you're saying I did, or you meant something else? Because I just tried it, but got this error.
I think Vrinda, this is Shannon, but I think maybe Vrinda was saying to right after you have not canceled and then the pipe.
Okay.
Just do sort.
Okay.
Try taking do sort. And then maybe count. I'm not sure, but maybe having that sort.
Then I pipe counts also, right?
Probably, I would think so. Maybe sort and then a pipe.
Okay, then count. But shouldn't a function shouldn't sort take there's no arguments in sorts and function. Okay, let me just run this and see, because will count now take the argument not cancelled. Should count then take the argument destination, or should none of the new functions take destination as an argument? Shannon?
Right. I think one of them should take destination. So maybe it's the sort destination, comma, descent, or we're trying to get it not descending, I think so. Or
That
yeah,
means decreasing will be true then. We're trying to get it not ascending, right? No, decreasing, that means from the topmost, from the highest to the lowest, that will be decreasing. Yes.
right.
Ascending is from the smallest to the highest. So descending.
It should be false, I guess.
Is that Daniel?
Yep.
Oh, descending false. Okay.
So let's see if this is gonna work.
Okay, it's loading. Oh, we got an error code again. I got an error code. Can we? Okay. The function descent should also work, but this time around, let's see if we do something. I saw what Mr. DME sent. So if we do it this way, maybe we'd get it then. Okay, we use the arguments. So what's going on? Or should we do this some other time? Should we check it again and possibly maybe drop it on the comment, drop it in the Slack channel if we find a way to get it solved? I'll just put comments here. So when I get back out, maybe we'll continue and figure it out next time. Yeah, we'll continue and figure it out next time. So we'll drop it in the Slack channel. Sorry for chopping it. No, it's fine. It's fine. It's fine, to Daniel. It's fine. We'll come back to it. I surely want to find a way to get that done, because I would love to see what it would look like when it's in descending order. Or we could just have, maybe if it's something, we could creatively just say, okay, tail, then comma, we make this an object. When we add it the first time, we make it an object, then we'll still find out what's at the bottom, if we are so keen to know what's at the bottom. But we'll still find a way around it though. Okay, so let's get back to the book down documents. Okay, I think there's a message. Maybe arrange function. True. Maybe arrange function. True, the arrange function. Cruz. Maybe I can't pronounce the first name, so permit me to pronounce Cruz. Say Cruz. Maybe we'll come back to that. We'll use the arrange function. We'll try that in our spare time and find a way to sort that out. But let's just continue now so we can complete this particular chapter. And okay, so optionally provide a way to be able to set a sum of that variable. So this time around, get the total number of mouse planes flew for each destination. I guess they want to know, okay, find out how long has the number of miles this plane has actually flown, and also know, okay, if it has been flying for this long, possibly they would have a reason to say, okay, for now, the number of, okay, for each destination, okay, that would be a total number of I'm just trying to like deduce why they want to find that, but I just found out that it's for all the planes that have gone that particular destination. So we can't say, okay, for this particular plane, this is actually for a destination. So we have it in the in the dimension 104 by 2 colon. So we have 104 destinations again, and we have 2 colons. Now we have the n is now the total number of miles covered flown to that particular destination. Miles plane flew for each destination. Okay, so next would be, when used with numeric function, true is converted to 1 and false is converted to 0. So when we say sum true, that's 1. Then sum 5 greater than 0, that's 1. Is 5 greater than 0? Yes. So that becomes 1. So it turns numeric. When using numeric functions, true is converted to 1. So sum is actually a numeric function. Counter proportion of logical values. Sum x gives the number of truths, and min s gives the proportion of true. So number of flights per day delayed by more than 60 minutes. Okay, now this next chunk of code will tell us the number of flights per day delayed by more than 60 minutes. Possibly they might try to find a way to cop such, or see if it's actually maybe some other reasons for this check. So number of flights, so how count 60, 79. So we have it's, I think it is arranged. Is it? Oh, it's not actually arranged. It's not arranged. But just on the first day, we had the flight delayed for close to an hour, and that's shocking. So let's move on. Proportion of flights per day delayed by more than 60 minutes. Proportion of flights per day delayed by more than 60 minutes. So this, we have them in proportions, 0.072, and still this is 365 by 4, and the data, I mean the dimension of data is 365 by 4. Grouping by multiple variables. Now this is another sub topic under this chapter, grouping by multiple variables. Now progressive loading up summaries for sum and count. Daily, we can group flights by day. So we can group the flights by day. So actually this will also most likely give us this actually is going to give give us an object with a table of also 365 rows. Let me run this in our grouping by multiple variables. No, it's not necessary. Progressive rolling up summaries for sums and counts. So grouping flights by day. So when we run this, check my environment. Okay, daily. Okay, it doesn't. Okay, I see it's different. We have it still. It's just grouped by. Then I think when we summarize is when it becomes 365. Sorry, I take that back. We don't summarize. We have it 365 by 4, and this time around we only have year, month, day, and the number of flights per day. So one thing that would be lovely to see, I don't know if you noticed that when we had the code in brackets, we didn't have to. Normally, if you want to check out, want the output of daily to come forth, we would have written daily and run it. Then we'll have the output below. We will have the output below. But for this particular chunk of code here, we didn't need to like type per day below because the entire code was also in another bracket. So putting another bracket makes the code run without us writing underneath per day. Another way of actually doing that, I know some of us might be aware of that already, is by putting, I think, a semicolon. Then we could put daily, and automatically, I think it sees the semicolon as a new line of code. So it's automatically just give us the output below. So that's one thing I actually found out also. So number of flights per year. Number of flights per year, and summarize object per month. Okay, I've not run per month, that's why it didn't come out. So per month, this data will be 12 by 3. So we have data. Let's look at this data and see what it looks like. Okay, so year 2013, and this is the 12 months, and this is the number of flights for each of the months. Majority of the flights were around 2,000, and we had the highest flights to be sometimes in August and sometimes in July and August. The July coming top. We had more flights in July than in August. I don't know why, because this is, I wonder, there must be a reason, possibly maybe the holidays, or I don't know, but there'll surely be a reason why there were more flights in July and August, or why July and August had the highest flight in 2013. Okay, someone dropped a message. Thanks for that shortcut. Oh yes, you're welcome, Mr. Daniel. Okay, so to the next, to this code that didn't run, let me run it again. Okay, this is just summarizing the entire data set by year. So for example, let's say we're working with a bigger data set that had more than just the year 2013, say 2014, 15, 16, 17. We can actually see summarized by year. and then we get to know, okay, the number of flights for each of the years. I think that is why we're just having just a table of 1 by 2, 1 row by 2 columns. So about ungrouping, okay, I learned something from the last quad when I got here, when I was watching their video again, and I saw how when you didn't group, or when the codes could hang, or you could have issues running some codes when a grouping is causing some challenges. So the best thing to do is to actually ungroup, then you can go back and do or run some other codes. But I don't yet have that wealth of experience in data science to be able to explain scenarios that will paint or picture such occurrence. So I don't know if other people have such, you could just share. So because I actually look forward to learning from every other person on this platform. So we'll be working with the data set daily that has been created from the flight. Okay, we work with daily, the Table daily, then the Table daily that was created from the flight data set, and we'll be ungrouping the count. We'll be ungrouping. Okay, we're removing the groups, and so we know that okay, the flights is just 1 row. Then ungroup the daily flight to count the total number of flights. Sorry, we're ungrouping to count the total number of flights. Then afterwards, if during analysis the data doesn't look right, okay, I think I've said this, you can try to use ungroup to check if the data was previously grouped. So now we'll go to, okay, let me go back to using the book down documents. Okay, yeah, I think we are here. Yeah, ungrouping, yes. So we're going to group mutates. Group mutate and filters. Use group and mutate and filter. Get the flights with the top 10 largest arrival delays per day. Now to do this, I think this is what's going through on our studio. Let's check top delays. So for example, should I find out a particular, say I want to make a decision on going with a particular flight or group, or no, how would I put it now? Okay, the only thing I can think of is, say I want to fly with Dana Air and Dana Air has top delays. I would not want to fly with Dana Air. So I don't know, non-Nigerians may not get what Dana Air means. Dana Air is just, okay, yeah, flight carrier, yes. I may not necessarily want to fly with them. Okay, goodbye, what's going on? Flights not found. Okay, I didn't run this earlier. So let me just saturate and flights. Yes. Okay, so I've run the codes, then go back to mutate, then run this again. I believe it worked now. Yeah. So now we're trying to get the top 10 largest arrival delays per day. And what we just did here was this particular this table flight 7 columns, which is okay. Let me check what is there. Let's view that particular data set. Okay. Flight 7 columns. Okay. Okay, I think this just have our data in 7 columns. I think that's just what it has our data in 7 columns. That's just the difference. I just don't see there was something special with data. But you know. Okay. I just want to check the dimension. Okay. Okay. It's still the same number of rows with the normal flight data set, but now just the difference is just the 7 columns, and I think it's the table that was created when we had to mutate the data set. Please explain filter rank. Okay, yes, I will explain that. Starting from group by, we are grouping flight 7 columns. That's the flight data sets having 7 columns. Then group by year, month, day, then filter. But while you're filtering, rank it by the descending order. Rank by descending order the arrival delay that is less than or equal to 10. Is that clear, sir? Mr. Daniel, can you get that? Did you get that? So what we just did is the top delay has been filtered in such a way, that it is ranked by in the descending order of the arrival delay column. Sorry, I'm coming. Yes, that's it. Okay. Script the amount per day. Script the amount per day in the future. Learn something like that. Okay, what it just did was it's just ranked the arrival, the 10 top 10 light arrival delays per day, and we have that for the daily trips, and any arrival less than or equal to 10. This is, sorry. Okay. There's something not right, because the data is not actually sorted in a descending order in any of the columns. Say, I mean, the arrive delay column is not sorted in a descending order. Okay, sorry. I just quickly want to check the help. Okay. Okay, Mr. Daniel, I don't know why this seem not to be, I think, get it clearly what the help document is saying of the values in a vector, sample rank of the values in vector. Values can be Can anybody help out here? Actually, you cannot best understand it, but it's not. Okay, someone dropped the message. Thanks. Noticing to the same argument does not seem to have an effect. Yes, I noticed that. I looked at the entire table that was formed. Nothing seemed to be didn't have an effect. So I was trying to find out what the rank function did, and could not find anything. But I'll still check it and possibly mention it. I'll check it up. And also, should anyone have any things to say about that, which really would appreciate. And okay, so add rank. Mr. Dan, do you mind I go on, or to possibly get a way to? Oh, sure. Okay, good. Add rank colon. Okay. Add rank colon and sort the rows by day and rank to check if top delay is returning what we expect. Okay, good. I think at this point, it actually is now in the descending order. Yes, it's now in the descending order. Mr. Danny, I don't know if you notice that now. And everybody I don't know if everybody saw that there's a difference now. Add rank colon and sort the rows by day and rank to check if top delay is returning what we expect. Now it's returning what we expect, but yet it wasn't. And I really wonder why we didn't get it initially, or why it wasn't returning that initially. Mutate.
Is the point
Okay.
for us to understand what group by could be doing, since the only difference that I see.
Okay, what group by does is it groups the data by year, month, and day. So okay, what I'll do next is, since we still have ample time left, what I'll do is I'll copy the same data. Then whenever I don't understand the code, what I actually do is I break the code in bits. Then from there I find out what could have happened, or why I didn't. Let me make this two. Okay. Let's see what top delay is. Top delay 2. Okay. So it groups the data by year, month, day, and they will be 365. And okay, I think someone dropped the message. Oh, because we didn't have a rank column in the first example. Because we didn't, well, yes. We didn't have a rank column in the first example. Yes, I was thinking that also, but yes, I think it's because we didn't have the rank column in the example. That in the first, the first chunk of code. Okay, filter. Say I take this out and use just rank. This one drop a message. Let's see. Link like a rank column as part of the data set. Yes, that's what she meant. We don't have yes, like part of the data set. I think that's what she meant. Okay, let's see if this would work. To did it 40 95 40 357 okay, and 595 okay. So what exactly does this do then? Did nothing. So what's the point of putting it in the code then? Okay. excuse me. Okay, sorry. Okay, add rank colon and sort the rows by day and rank to check if top delay is returning what we expect. Yes, I think it's the rank colon. Once you add the rank colon, you would would get what we actually would get it in the descending order, and that's what actually happened here. That's what happened here. The arrival, yes, arrival delay was now in descending order. Okay, at this point, I think we have successfully covered chapter 5 according to what's here. So we're going to Mr. Daniel. Do you want to say something? Because we're done with chapter 5. Hello. Should we go to chapter 6, or chapter 6 is just?
Yeah, I mean, I guess if we could manage it, I guess we could probably do it. But we have like, we probably get like
7 minutes. Yeah.
This is something we can speed through.
Okay, so chapter 6 is just we talking about our studio, how it works. We have about 4 pages, I think. I'm trying to get it to load the book down document to load, but okay, maybe I'll just go straight down to my house. Start out chapter 6. Yes, I think with this I could just mix the documents, then okay, 100%. Beautiful. Okay. Yes. So the use keyboard shortcut to use the r4ds script pane effectively. I think there's also a shortcut for a pipe operator. I think I mentioned that last time, called sheet M. Understand the scripts diagnostics that the r4ds script editor provides. I think that's the whole objective of chapter 6. Is this all? Is this all there is? And I should use the book instead. Okay. There is the book. Yes. Is my screen showing the R Studio books, the R for data science book itself? Come back to the chapter saying yes. Okay. Now this is the book. Okay. I think I have it in another tab. Data science. Okay, chapter 6 workflow. Okay, so so far you've been using the console to run code. Well, we've not been doing that. We've actually been using the book down option. That's a great place to start, but you'll find it gets cramped pretty quickly as you create more complex G+2 graphics and deployer pipes. To give yourself more room to work, it's a great idea to use a script editor and open it up either by clicking the file menu. Okay, to open the script editor, it's quite easy. All you need to do is come to the file menu here, and you can easily just pick a new file and create a new script, and it has a shortcut r4ds, or you can go ahead and make your code much more beautiful, like what we are doing here with this R book down book by using an R markdown file option, or you could just go ahead and you could even use any other script. You want to use you want to use Python code, or you want to use SQL or Stan, which is for Bayesian data science. I think you can just pick any of the file type you want, and R will make it possible for you to work with that. So the pane is divided into 4. From my R Studio, it's actually in this part shows the environment, the history of what is being done, connections, the build. Then if connected to the GitHub, a repo, repository on GitHub, you have it here, so I can easily pull or push what I'm doing. But actually, I've been finding I've not found a way to create my own branch, because I saw some typos I wanted to make corrections to and push, but I've not been able to do that. I wish there was a way I could learn to do that too. Then to get tutorials online on how to use R, there's a pin for that. So this is where you get to see possibly the Markdown script or the new scripts which is being created, which you can easily create. Then back to the workflow parts. The script editor is a good place to start with code you care about, keep experimenting in the console. But once you've written code that works and does what you want, put it in the script editor. Running codes, the script editor is also a good place to build your complex. Okay, I think we mentioned that. Okay, let's let me create a new file. Oh, where's our studio? Okay, create a new file. File new. Control Shift N. Okay, so just run. Okay, so what this part just does is we just, instead of running expression by expression, you can also execute the complete script in one step by using Control plus Shift plus S. Then you can run the whole thing straight up by just using that shortcut. Doing shortcut is a great way to check that you have captured all the important parts of the code in a script. And then it is recommended that one always starts the script with the package that is needed. So that's why most times when you see some R codes on some YouTube videos, it always starts with install the necessary package needed, import the package, then the next chunk of code will now be you importing the data set, the next chunk of code will now be you cleaning or preparing the data set for analysis, then the next chunk will now be you doing the proper manipulation, then other things, then just the normal workflow of the data science project. And when working through future chapter, I recommend starting the editor and practicing your keyboard shortcut. Over time, sending code to console in this way will become so natural that you won't even think about it. And I know several of us have been doing that, and we actually will keep doing that. I actually need to learn more. Okay, now the script, RStudio diagnostics, the script editor will also highlight syntax error with a red squiggly line and a cross in the sidebar. I don't know if you noticed that the other time when we were working together on the top delay object. There's a time I broke the code here, and okay, no, it wasn't here. I broke the code with the pipe function and showed the squiggly line, the red squiggly line, and that means that the code is not complete or something was wrong. So it's telling us something is wrong with the code. I think it will soon show that same error again. Why is it not showing it yet? Showed it the last time. Okay, let me just copy that code that was written there. I think what was written there was x space y 10, I think. Then there was an error afterwards. Okay. I don't know why I'm not. Okay, yes, this is it. We get to know unexpected y token y or unexpected token. So one of them will be wrong. Yes, this is squiggly line I was actually looking for. Okay, so this is what was mentioned. So with this line, I know that, oh, there's actually an error somewhere that I need to actually fix. And this will actually give us an idea, okay, unexpected token. So I need to take this out, or possibly there's something I have to actually complete there to be able to get what is expected. So yeah, I know either I take out X or I take out Y, or maybe I forgot my underscore. But once I put that there, I think the red line and the other, yes, would disappear there. Oh, what's going on? That should not be there again. Okay. Okay, so yes, then I need to take this off or get it back with the other set of codes and it would work. So most times I need to look for a meeting. Thank you so much for leading a good discussion, Matthew. Oh, you're welcome, Brenda. Okay, I think it's time we leave Mr. Daniel. This is 7:02. So hopefully next class we'll be talking about EDAs and talk about a whole lot. Then we could try the exercises on our own. Shannon, thanks, Matthew. I like the way you presented with both the book down files. Yes, I was trying to do that the last time, Shannon. I forgot to share the screen and all. Oh, thanks, Matthew. You're welcome, Mr. Daniel. Thank you so much for having me. I hope to learn from everyone. Thank you for the presentation. That was very helpful. Thank you to Maria. You're welcome. Thank you for listening. Thank you, everybody. At this point, I guess everybody is leaving. Thank you so much for your time. Look forward to seeing our faces again. Oh, don't worry, I'll work on my video and possibly we'll get to show my face next time we meet. Have a wonderful day, everybody. See you next week. See you next week too. Yeah, Mr. Daniel. So I'll still check out those things that those questions you brought up when you say chat log. I'll still check them out then. When I find the solutions, I'll let everyone know about it. Cruz, thank you. I really do not pronounce first name. I hope you pronounce it for me, so I'll now pronounce it properly. Esmeralda. Oh, so. Okay, guys. Thank you. Yes, both are correct. Oh, thank you. Esmeralda. Okay. I have to go also. I have to go my way. You know, Nigerian traffic. So I have to go and face it now. I have to leave. Bye.